The topic of this video is simplifying rational expressions. What is a rational expression? A rational number is also called a fraction. For example, 72 over 90, we usually call this a fraction, but it's also called a rational number. If we put variables on the top, x squared y or xz on the bottom, and we call this a rational expression. And because we don't just have numbers in there, we also have variables in there. And that's why we call this a rational expression. Now, in order to learn how to simplify this rational expression, we're going to recall the process of simplifying a fraction, which is also called a rational number. So what we do is we try to figure out what number can go into both 72 and 90 and reduce it, and then if you see something else that goes in there, you can reduce it. So there are several different ways you can do that. So if you can say, for example, I see that 9 goes into both of them, I can divide both of them by 9. And then the top, 72 divided by 9, that will give us 8. And 90 divided by 9, that will give us 10. And then we see 2 goes into both of them. We can divide both of them by 2. And that gives us 4 over 5. That's just one way to do it. But if you can see 18 goes into both of them, we can go ahead and divide both numbers by 18. But usually it's hard for us to see that 18 goes into both of them, because 18 is sort of big. But if we can, then of course we get 18 goes into 74 times, and 18 goes into 95 times. So there are different ways to do the problem. And if you can't even see that 9 goes into both of them, and we can also do the other way to break down each number. So instead of trying to just figure out what number goes into both of them, we can break them down, and that will help us see what number goes into both of them. So for those of you who have trouble seeing what number goes into both of them, we can break down 72. For example, 72 equals 2 times 36. Maybe I can use a factoring tree to do it. Let's break down 72 here. 72 equal, breakdown is 2 times 36. And 36 is 2 times 18. And 18 is 2 times 9. And 9 is 3 times 3. So we're going to write down those prime numbers, 2, 2, 2, the numbers on the like the tree leaves. We have 2 times 2 times 2 times 3 times 3. And similarly, we can break down 90. 90 is 2 times 45. And 45 is 5 times 9. And 9 is 3 times 3. So we can write down these prime numbers, 2 times 5 times 3 times 3. After we break down everything, this process is also called a factor. So we factor the top, and then we factor the bottom, and we can see what they have in common now very clearly. And notice that the top has a 2 and the bottom has a 2. So that means 2 goes into both of them. And then we also notice the top has a 3, bottom has a 3. We can divide them by crossing them out. And then there's another 3 on the top and another 3 on the bottom. Now when we look at the numbers left, they don't have anything coming anymore. So notice that this first 2 that we cross out corresponds to the process we did right here, dividing both numbers by 2. And the 9 we crossed out, 3 we crossed out a 3 and then another 3 together. It's multiplying, and then it's a 9. So corresponds to the process of dividing both by 9. So that's a different way to do it. So usually if you can see what number goes into both of them, say 9, you can go ahead and divide both of them by 9. But if you have trouble seeing it, you will have to break down, or you call it factor each number. And you can now see very clearly what number goes into both of them. So we can write down the final answer. The top has 2 times 2, that's 4. The bottom is 5. So we can see we get the same answer. So this process might be a little bit tedious because we have to break down the number all the way, factor the number all the way down to the prime numbers. For this is the process we're going to follow to simplify rational expressions. So let's look at an example. Now, this looks like a fraction, but it has variables in there. We call it a rational expression. In order to reduce this, we're going to follow the same steps we did here. So if you look at the steps we did, the first step is to factor the top and factor the bottom. So we're going to write down the steps here. Notice that we first factored 72, the top, and then we factor the bottom 90. So that's the first step. Factor the top and the bottom. And then after that, we after we factor everything, we can see what they have in common, the top and the bottom. And then we can cancel all the common factors, like 2 and 2, 3 and 3, and copy down whatever are left. So we're going to do the same thing here, follow these 2 steps. So step 1, factor the top and bottom. So the top, notice that a negative number divided by a negative number will give us a positive. We can go ahead and just ignore these 2 negative signs. 2 negatives make a positive. Now we're going to break down 28. And notice 28, so let's break down here. 28 is 2 times 14, and 14 is 2 times 7. So we're going to have 2 times 2 times 7. And similarly, we can break down 63. 63 is 3 times 21, and 21 is 3 times 7. So when we break down factor 63, we get 3 times 3 times 7. And then we can break down a squared, where a squared also means a times a, and the top of b squared means b times b. Do the same for the bottom. For the bottom, we have a squared. A squared means a times a. And b cubed means b times b times b. Multiply 3 copies of b. Now we can cross out the common factors from the top and the bottom. The top has 2, but the bottom doesn't. The top has a 7, and bottom also has a 7. We cross them out. And we also find that they have this a in common, top a, bottom a, top a, bottom a again, and top b, bottom b, and top b, bottom b again. So we're going to write down what's left. The top, we have 2 times 2 is 4, and everything else is crossed out. The bottom, we have 3 times 3, 9, and there's also a b left on the bottom, which is not crossed out. So that would be the final answer, 4 over 9b. And notice this process is also a little bit tedious because we have to factor a squared, or use the definition means a times a. But if you understand that the process, you can go ahead and cross out a squared and a squared together. And so what we can do is the other way to do the problem from the process, because the top has 2 a's, bottom has 2 a's, we can cross out the 2 a's together. So we can cross out a squared and a squared together. But b squared and b cubed, notice that the bottom has an extra copy of b. So we can only cancel out the common factor b squared, and we will still be left with the b. And so if you do this way, you're going to get the same answer. And also similarly, 28 and 63, if you know that 7 goes into both of them, you can divide both by 7, because 7 goes into 28 4 times, and 7 goes into 63 9 times. So you can get the answer very quickly. 4 on the top, 9b on the bottom. But if you have trouble seeing this way, doing this way, you can still expand everything, factor everything out. Okay, so the process, the steps, first to factor everything. If you have trouble doing that directly, and you cancel all the common factors. But later on,